Hello again. I am Senior Master Sergeant Rick Detlinger, and I'm with the U.S. Air Force Aircraft Metals Technology Program Office located here on Robins Air Force Base, Georgia. This is the second video in a series of 3 that is detailing how to perform temperature uniformity surveys. In this video, we are going to cover the software that comes packaged with your SSI SDS 8120 data logger, and we're going to cover 3 primary areas. Number 1, we're going to cover how to connect your data logger to your computer so the two can communicate and be able to download your data. The second point is actually downloading your survey data, where once your computer and data logger are connected, we will go through the menu options to pull that data into your computer. And then the third main point is once we have that data downloaded, we're going to go through and actually fill out all the tabs to generate a TUS report. Your TUS reports are going to be filed for your records maintenance purposes, and from there in the future, if you ever had an audit or had to produce said records, you could pull up your TUS report and show them that your oven is in fact operating within the specified parameters. So let's go ahead and get started. Alright, so at this point I already have my laptop or your desktop, whichever one you want to use or that you actually have at your unit. Have it up and running. It's booted up, ready to go. I have my data logger booted up, ready to go. So let's just say at this point we have ran a survey and we are ready to connect our data logger to our computer. All you're going to do is get out the USB cable that came with the data logger and plug the end that fits into the data logger into it, and then the other end, the standard USB end, into your computer. So you can do that with your SSI software already open, or you can do it while it's closed. It doesn't really make a difference. One thing that I want to show you before we actually connect the data logger to the computer is something about the software itself. I'm not going to go through the procedures for how to actually download the software and install the software onto your desktop or laptop, because you guys are all familiar with how to do that. So I'm simply just going to cover a couple of key points with the software itself. Now, your software should already be updated from SSI. One thing that I requested they do, since some of us actually operate on standalone computers, is ask them to ensure that they ship their software, sorry about all this choppiness, that they actually ship their software with the most current updates already pre-installed. So we will open our SSI software and look for a few options. The main thing you want to look for to ensure that you have the most common software installed is the Options tab. Let me zoom in here a little bit. So you're going to want to go to the Options tab, which is right up here, and look and see if you have 4 options with check marks next to them. The 4 options I have are multiple SDS mode, show labels on chart, color screen scanning, and shade data grid values outside tolerance. If you have those 4 options with check marks displayed next to them, then you're good to go. If you have the 4 options showing but they are unchecked, go ahead and check all 4. If you don't have all the check marks displayed or all 4 options displayed, then your software won't operate properly, and you'll have certain functions, primarily being able to download your data from your data logger, won't be available to you. This is really, it's probably an older problem, but I'm fairly confident that SSI is shipping their product with new software. So if you don't have those 4 options, what you're going to do is go to the Help menu and click Install Color Prerequisites. Mine's already installed, but I'll pull it up, and so it already says, it's already installed, so it's good to go. Other thing that you can do is, if you're on a network computer, you can go ahead and check for updates. If you have a standalone computer, then you're going to have to call COM or find an internet source to check for updates. You can't download updates onto a disk and then bring that disk over to your computer and click install updates or anything like that. You can only get your updates from the internet. So if you have any questions about that, give me a call in the office and I'll explain more about that. So if you do have, or you have installed your color prerequisites and everything is good to go, and you now have your 4 options and 4 check marks showing, we're ready to move on. So again, all of that really only applies to you if you have an older version of the software. You were an early adopter, if you will, and you got the data logger right when I put out that memo in the early summer time frame of 2015. But if you recently got your data logger in the past, let's just say 8 to 12 months, you should have no problem. It should arrive fully updated and have all these check marks. But I still recommend that you do check for updates, because times are always changing and they may put something out even after this video comes out. So with all that being said, let's go ahead and connect our data logger. So all you're going to do is, again, connecting cables is not rocket science. You probably don't even need to see this, but I'm going to do it anyway. You can plug this data logger in with your SSI software already being opened, or you can do it with the software being closed. The primary thing that you're going to look for is this little icon right here. So I'm going to close it because I already had mine hooked up once before. But so right now, software is open. Again, you can do it if it's open or not. So what you're going to look for is that same box I just showed you. The icon's going to pop up. So that box pops up. The key thing here is that it says connected, right? You guys all see that there. And again, most of you guys are probably familiar with this, but if you're not, well, we're talking about it anyway. So it is connected. Our 2 devices are talking, so we're good to go. Go ahead and minimize that menu. And then from here, once you're connected, all you're going to do is go to the SDS tab, click on it, and then your second option, download surveys and data. You're going to click on that. This box will pop up. It's the SDS data downloader. It'll say searching for host or SDS, and it'll communicate and it'll find it. So mine has found my data logger. It says 1 SDS found. And so I'll move to the download tab in the lower right hand corner and download my data. Depending upon how many surveys you've ran, this will take anywhere from 30 seconds to 3 minutes. I've run quite a bit of surveys, so you see it's doing its thing. You guys most likely on your first go round won't download this many because you'll only have 2 or 3 to choose from. But I've performed quite a few already, and so I have a lot. So operations complete. A little menu pops up, tells you op complete. Click OK. OK, and close the second menu. At this point, you have connected your data logger. You downloaded your survey data. Now we're actually ready to go in and create a report. So we have 2 options here. You can click File, New, which will open up a TUS report, or you can simply click the New Paper icon in the upper left hand corner. Either way you choose to do it, it accomplishes the same exact thing. Alright, on this software, all you have to do is fill in the blanks. So let me just say that this software is written to a higher standard than what we actually need for our Air Force purposes. So we are not going to use all these tabs that you see here. We are only going to use everything from controller and to the left. So 1, 2, 3, 4, 5, 6, 7. The first 7 tabs are what we are going to use. If you're a little more advanced and you have some user-defined parameters, you can actually plug those in to the user-defined tab. And the last two tabs, the comparison check and comparison check 2, those were actually written for manufacturers such as Lockheed and Boeing that have additional specifications that they require of themselves to perform heat treating operations. So for our purposes, we're only going to use the first 7 tabs, which is report, survey parameters, survey details, thermocouples, survey box, furnace, and controller. Your primary 3 tabs up here are report properties, which are where these 7 tabs are. I guess we'll call them secondary tabs. And then your other 2 primary tabs is a chart and data. Right now they're blank because we have not yet selected a survey to compile a report from. So all we've done is downloaded all of our data, but each individual TUS that you run is an individual data packet. So you will see that here. So I'm in the first primary tab titled Report Properties, and then the first secondary tab titled Report. I'm going to go to Data Sources. I'm going to click on this little button with the ellipse, and I'm going to select a survey in which I want to compile a TUS report from. Normally what you would do is you would just pick your top survey because that's your most recent survey, but I'm going to pick one a little further down the road so you guys can get a good representation of something I want to show you. Okay, so I'm going to select the survey I want to use and then simply click Use. So that pulls up some data already. You can see a menu populated because of data I input into that template on my data logger. We talked about that a little earlier in the first video, so we won't go into it here. But if nothing pops up, don't worry about it. The key there is you have data input in the data box. Second thing we're going to select is report template. Now, when you guys select report template, you're most likely only going to have the sample report template, which is what comes from SSI with your data logger. That's fine to start with. I have gone in and made some minor modifications to the standard report template, which is detailed in your data logger manual. It's a fairly simple process to do. I figured it out. I'm not the most computer literate guy. I'm not computer illiterate, but there are many men and women smarter than I when it comes to computers. So if this guy can figure it out, you too can figure out how to modify your report template. I'll tell you, the really only thing that I changed was I didn't like SSI's standard TUS map for my thermocouples, and so I deleted their link in their report, and I then drew my own map and took a picture of it and then uploaded that into my report template, so that it's what I want, right? Half of running a TUS is defining your operation and then testing your operation, and so you don't have to TUS per se the way someone tells you to. You have certain parameters you must follow, but the parameters that you can change them and then test said parameters. So anyway, moving on before I get too far off subject. We're going to go ahead and use the sample report template just because that's most likely what you guys are going to have. And then I will click Open, and then it pull up the report template. From there, all we're going to do is fill in the blanks. But before we do that, I want to make sure, I'm going to go back up to my primary tabs of chart and data and click on those. So we'll click chart. You'll see some that we have actually imported some data. That's what I'm actually showing for the survey that I ran. That is the graphical representation. The scale that's being shown was set on my data logger. So that was chart scaling, if you recall that. So I can, even in this program, I can still change my chart scaling, and I can zoom in on this so that it only shows exactly what I want to see. I can make it smaller or bigger, whatever you want to show. The next tab is your data tab. So your chart is a graphical representation. Your data tab is a numerical representation. So when you're looking through here, you have your time and then all your thermocouples, all 9, listed out for at 1 minute increments. The requirement for your survey is the minimum 30 minutes, and so you'll see here that we have right here at this grayish bluish line, it's 9:56, and it runs to about 10:40. I'll explain this to you here in a minute. So again, you have report properties in your primary tabs. You have report properties, chart, and data. Report properties is where you go in and actually fill in the narrative of your report. The chart is a graphical representation of your data, and the data is a numerical representation of your data. I will say that I personally prefer the data because, like I said in video 1, numbers don't lie. This is accurate to 1/10 of a degree, and your chart is not as accurate. The scale of your chart or the resolution is not high enough to show you a deviation of 1/10 of a degree. And so you can have one of your thermocouple colors there, as indicated, riding that line of your high or low spot on your graph, and it could actually dip above or below your line, but you wouldn't see it because your tolerance lines, as indicated by those 2 thick blue bars, are thicker than your TC indicator line, and so that your tolerance lines could hide that deviation of 0.1 degree below or above your tolerance. So that's why I choose to read the data chart, which we'll talk about when we get back to our report properties. But that's why I choose to look at that in conjunction with my graphical chart to verify the SDS report of pass or fail. So now that we have the data downloaded and the report template downloaded, we're going to give this a title. You can call it whatever you want. Wherever you're at, you can say base X, lower chamber, if you have one oven, right? Lower chamber, comma, I don't know, 350. Right, something simple. And then survey results, pass, fail. Okay, you might ask yourself, well, why wouldn't the data logger software or the SSI TUS software tell me pass or fail? Well, because there are such things as temporary thermocouple failures that are allowed as long as your thermocouple recovers, that the computer may see as a temporary fall out of your tolerance range and mark that as a failure, whereas the human ability to make allowances, computers can do it too, but you can interpret data and go, okay, according to AMS 2750, it allows us to have temporary thermocouple fails as long as they recover and the temperature was within the proper range prior to failure and after failure. It's good to go. So there are circumstances where you have to use your human interpretation and call it pass or fail. So for this case, prior to saying pass or fail, we'll go to our chart. What you're seeing here is I brought my oven up to temp. I let it run for a little while to stabilize. Once I was sure it stabilized, then I performed, just for the purposes of doing a pure TUS survey, I performed a simulated parts load. So what that means is I already had my rack in the oven, my simulated parts load, I open my door, you have your huge temperature drop, put the part in the oven, right, simulated, close my door, and then begin my approach. And so at that point in time, I'm tracking the recovery of my oven, and then how long it takes to recover, if I have any overshoot while it's recovering, and then once that it has stabilized, I began my actual survey and tracked that time for 30 minutes. So that's what you're seeing here. Now to explain that, you can actually go up here, and with these options in the upper left hand corner, you got zoom, you got pan, and then a restore graph. So any changes you make, you can restore it. So I'm going to zoom, and just to try and show you guys a little bit better everything I just told you, I'm going to drag a box over the chart that I want to show you, and then let it go, and then now it brings it up in much greater detail. So over here, you kind of saw it was the same as looked over here, a bunch of lines, riding waves, right, as your heating elements cycled on and off. So I was happy with my stabilization, temperature uniformity, simulated parts load, close the door, mark my approach, temperature returns, stabilizes. Oh, it was a period of about, I don't know, 7 to 9 minutes. It was stable, so I was happy. I began my approach, ran it for 30 minutes minimum, and then terminated my survey because it was obviously continuing to perform well. I had captured my 30 minutes, terminate survey, and come in here to download my data and compile my report. So with this one, there's no real danger, right? All of my thermocouple lines, all of my reported data for my thermocouples is well within my upper and lower tolerance lines, right? So at this survey, I was running it at 920 plus or minus 10 degrees. So my range is 910 to 930. But I'm a creature of habit, and so I'm going to look at my data anyway. If I had a line that was really close to the lower or upper limit, you definitely want to go to your data tab. But like I said, it's a good idea to always do it anyway. So let's look at time hacks here, right? So before we do that, I'm going to explain these colors. Everything white is within operating parameters that you set into your data logger prior to running your survey. Anything in this bluish gray is indicating cold, and if it is red, I don't know we'll get any red here, but if it shows red, then that's hot, right? Go figure. Blue, gray, cold, red, hot. Yellow is indicating the termination time of your survey, and that's about it. So the key thing you're looking for is blue, gray, white, and red. So again, red is over temp or over your tolerance, blue-gray is cold, under your tolerance, and white is within parameters. So everything's within parameter. So what you're looking at here is my short stabilized period, my simulated part load, where I went from, let's just say, 920 range, dropped down to the lowest one is 714. But so anyway, it's really cold for this minute time frame, right? And then it begins to ramp back up. So I open my door, simulated part load, close my door, and then within 3 minutes, my oven had recovered, and I was ready to rock and roll. The actual allotted amount of time per AMS 2770, which is for heat treating aluminum, is 20 minutes. So we're well within our parameters there. So if we go back to the chart, you can see all that. So here's 10 a.m., 9:59, 58, 57, 56. So you can see right here in that 56 to 57 time range is my cold spot. Back to the data, same thing. 9:56, 9:57, bleeds into 9:58 a little bit. But these two charts correspond, and I have no issues all the way through, I don't know, about 10:40 or so. So we'll go to the data. This is 9:59, scrolling down, 10:25. And then here's 10:40, where I terminate survey, and even past that, I still had no issues. So one thing I want to mention to you guys is, when you turn the data logger on, it is always logging data. So if you have your data logger turned on and your thermocouple's connected, it is always logging. So regardless of whether you tell it start survey or begin approach or end survey, it's capturing data. So really it's just markers that you plug into your charts and data graphs that show up, but again, your data logger is always recording data. So with that being said, this survey is a pass, and that will appear at the top of every single page of your TUS report. Notes. Now these notes, I plugged that into the survey template, as kind of talked a little bit about in video 1. Prior to performing a survey, you can go in and edit your survey template. And so my rack was 10 by 10 by 24. The actual volume, right, the zone, I called it a working volume or a qualified working zone, qualified working volume of 10 by 10 by 24. If I recall properly, this oven was probably a chamber size of 12 by 12 by 36. And so 10 by 10, side to side, and there's no real room for wiggle as far as placement, but front to back, if it's 36 inches deep, I only sampled 24 inches. I'm going to want to say something about how I placed the box. You could say something like furnace TUS was sampled at a working volume of 10 by 10 by 24. Rack was centered on the chamber floor and elevated 1 inch off the, I don't know, let's just say floor. So basically, that would tell me, without getting too specific, that my rack was, it had 1 inch on each side, left to right, of my rack from my heating elements, and I had 6-inch gap from my door to the beginning of my rack, and 6-inch gap from the back of my rack to the back of the chamber. And that finally, I actually placed my rack on top of, say, something I have inside my chamber to facilitate airflow, which is how you guys should be heat treating parts. And so that way, again, my 10 by 10 by 24 rack had 1 inch all the way around, and then 6 inches space front and back. So that's important because every part that I heat treat that fits inside this volume has to be placed in the same manner that this volume occupies. We'll talk more about that in video 3, actually running a survey. So once we have those blocks filled in, go to survey parameters, survey tolerance 10. Again, some of this stuff is pre-populated if you edited your survey template in your data logger prior to starting your survey. If you didn't, these will be blank, not a big deal. You just fill it in. Survey tolerance plus or minus, so you just tell it your number, 10. Set point for this survey was 920, plug that in there. Over temp set point, I probably had it at 950, but it's wherever you set it at. Don't set it, if your set point is 920, your tolerance is plus or minus 10, don't set your over temp for 930 because you just might over temp, especially if it's in your initial ramp up and your oven's not stabilized. You might over temp, and that's not a big deal because you don't have your parts in your oven while you're ramping up if your recipe doesn't call for it. So you don't want your oven to shut off. So set it at a reasonable over temp, 30, 50 degrees over, and then you can modify it as necessary as you begin to perform the heat treat process. But 30 degrees is not an unreasonable over temp set point. Heating, cooling, it's a drop down menu. For this one we're heating. Next tab, survey details. Company name, I just got USAF. You can put whatever base you're at. Survey start date will be pre-populated. You cannot modify that. That will come from the data logger. Survey duration, minimum required is 30 minutes. So I just plug that in there. The actual time, 30 minutes 40 seconds. That will come from your data logger. You can't modify that. Survey specifications for us Air Force users, our TO will be 1-1A-9. Performed by, you plug in your name, whoever performed it, the approved by will be your 7 level. Data range for survey. Now this is actually a typo. It should say date range for survey, and so simply plug in there. Currently I believe the TO says every 6 months, so let's just say today is the 21st of November. This would cover 21 November through what, 21 May. Am I right? No, I think I'm wrong. Yeah, something like that. So next survey due date, let's just say 21 May. Wait, let's be specific, right? 2017. So as you can see, this is not very difficult, filling in tabs. Next tab we got to fill in thermocouples. Thermocouple settings, temperature, Fahrenheit or Celsius. We're Fahrenheit. Number of TCs, thermocouples, 9. This section here is pulled from your data logger. It's 9, right? We had 9 TCs turned on. If you recall that from video 1, we turned on 9 thermocouples, so it reported data from 9 thermocouples. TC type K, TC gauge 20. The gauge is obviously how thick your thermocouple wire is. If you're ordering what I tell you or recommend, you're getting 20 gauge thermocouples. If you're getting your own, if you're getting something different, that's fine. Just make sure that you know what you're getting and you input your data properly into your TUS report. Thermocouple spool number, that came actually off of your spool. Showed you guys that in video 1. But if you don't know where to find it, it should be affixed to your spool, or if you bought spool type thermocouples that came in loose, it didn't actually come on a spool, it should have came with a small data card with that thermocouple wire, and you should have saved it, and that will be the spool number you input there. Thermocouple calibrated by whoever was your manufacturer or supply point. That should be who calibrated your thermocouple. Mine was Omega. Calibration date, I don't know, 21 Sep 2016. It'll actually say it. I'm just making stuff up to plug it in there. TC spool correction, that is pre-populated because you have to put that into your data logger prior to performing your survey. That was our spool correction. Again, back from video 1, my spool is -4 degrees, so that says -4 degrees. At this point, you can enter a new offset, but I'm not sure if it'll allow you to do it. Let's see what happens. This is just purely experimenting. Okay, so it did change it, but I'm going to go back and make it -4, because that's what mine actually was. Okay, active thermocouples 1 through 9 checked. Yeah, we're good to go. These are define, control, thermocouple, view instrument correction, offset used in survey, view individual TC wire correction factors. I'm not going to worry about any of that for now because most of you are probably using spool type thermocouples. But if you do have individual point calibrated thermocouples, go back to video 1 and you'll see how to input that data, which will in turn populate from your data logger. Okay, next tab, survey box. Survey box make and model, survey box serial number. These are all things that will be pre-populated from your data logger. You can't modify it. Survey box calibrated by, mine is here on Robbins. So I just put Robbins Air Force Base PML, survey box calibration date. Look on your calibration sticker. Mine was 2016 05/12. Moving on, furnace. Furnace ID, I said CACRL number. I just put that as a placeholder. As I travel around, I plug in your serial number. So let's just say here it's SN1234. Plug in whatever your serial number is, or however you track your furnace, right? It's your furnace, it's your system. However you guys track your equipment, plug it in there as applicable. Furnace make and model. This one was Lucifer HL82K36. Again, it's pre-populated because I entered it in my data logger. If it was blank, plug it in now. Furnace type, electric. It could be, combustion, right? Like a gas-fired furnace, something like that. It could be a salt bath if you have one of those, but most likely it's going to be electric. Furnace use, solution / precipitation heat treating. Maybe you also anneal or temper, whatever you're doing. But for this point, my furnace, primary purpose, solution and precipitation heat treating. Furnace operating range, this chamber was 100 to 1200 degrees. Furnace dimensions, just this chamber, right? Not your overall furnace, but your actual chamber that you're surveying was 12 by 12 by 36. And last but not least, furnace class 2. The furnace class 2 is plus or minus 10 degrees. So that's what you're going to look for. That comes out of AMS 2750E, current revision. And if you're doing a different furnace class, you can change that up. I click before I'm speaking. Load image map, right? So you have a standard image map that comes with your SSI software. Since we are using the report template, there's already an image map in there. But like I told you earlier, I drew a picture of an image map that I like to use, and then I import that into it. If you use the standard SSI template and then you also import an image map like I did, you're going to have two image maps. You're going to have the one that SSI is preloaded, and you're going to have the one that you've just loaded. So share what you prefer. You could just utilize their image map, and it's not a big deal. If you choose not to use your own, then cool, so be it. Press on. Just make sure you route your thermocouples the same way that they do, but I prefer to do my own. Controller. Here's where you're going to input the controller from your oven. Most of us have Honeywells. Most are going to have a UDC 3200 or a UDC 2500 or a UDC 2000. It'll either say it on the actual controller name, or you can pull it from your operator's manual. Just make sure you input accurate data. Instrument type D. Again, this could be A, B, C, D, or E. Most of us are going to have instrument type D. Type D is a primary thermocouple that records your oven temperature. You'll have a thermocouple that reports to your chart recorder, and you will have an overtemp controller thermocouple. So you won't see three thermocouples in there. You probably only see two in protruding into your oven chamber, and those two being your actual chamber temp and paper chart recorder thermocouple, and the second one being your overtemp controller thermocouple. So most likely instrument type D. If you have any questions on that, refer to AMS 2750 or give me a call here in the office. From here on out, after you put in your temperature controller settings, the rest is all optional data. The PID settings is optional, right? If you know how to pull the PID settings out of your controller and you want to input them here, more data is better than less data. Not required, but it will help with auditability. If any inspector ever comes around wanting to see these types of data, he can't say show me because it's a requirement, but if you have it, he might be impressed and say, man, you guys really know what you're doing. So it's up to you if you want to put that in there or not. You can get your manual and see how to open up your controller and pull up the PID settings. I won't go into them, but long story short, PID settings control how your oven ramps, how quickly it heats, how quickly or how long it takes to heat, cycle times between how long or short your heating elements cycle on and off, at what point they cycle on and off, so on and so forth. It's really good things to learn about and know, because you can really change, improve, or negatively affect how your oven operates. So let's move on to these last three tabs. User defined. These would be things if you have specific settings for your oven or operating parameters that you want to define and have documented, you would enter them here. But again, not required. The comparison check and comparison check 2, these are primarily for Boeing. And again, as I said earlier, SSI has over-engineered this software and this product to allow, I guess you could say, original aircraft equipment manufacturers to use this. Boeing or Lockheed or contractors that make parts that have to adhere to Boeing or Lockheed specs. So for our field level maintenance purposes, these three tabs aren't required. I should say the comparison check and comparison check 2 are not required. User defined, totally optional. And on the controller tab, once you complete temperature controller settings, the rest becomes optional. So you're done. Alright, so from there, once you have that all completed, you're going to click on the print button. The first time that you click print is going to generate a print preview. Okay, when you have your print preview, you can go back and review this and make sure everything looks okay. But I'll tell you what, let's go back and let's click save. And I'm going to save this in FY16 TUS reports. And so this is simply saving it. So if anything happens, I don't lose everything I've already done. Now I'm going to click that print preview and review my report. Let's see if I can make it a little bit bigger. Alright, so on this print preview, go through and just review it. Everything we've input: basic, lower chamber, 350, furnace ID, furnace make and model, time, all that good stuff, serial number, furnace dimensions, operating range, everything we input, right? Let's go to, you can only scroll one page at a time. So you have to go to this upper right hand corner and click the next page. Kind of a weird system, I know, but it is what it is. Alright, so I had some extra information there, so it fell down to the next page, calibration, so on and so forth. Next page. So look, if you look up here, right now there's a glitch, the S is not showing, whatever, but survey result passed. That's how I told you to be at every single corner of the page. Again, this is just all the information that we put. Fahrenheit, TO, overshoot, no, overshoot time, never happened, survey start, date and time. I ran this survey July 28th, 2016 at 10:09. Survey end date and time, July 28th, 10:40. So you can see I have my my greater than 30 minutes. You can go much longer than 30 minutes. You can go an hour, 2 hours, 3 hours, whatever you want to do, as long as you have 30 minimum. Displayed values are corrected because we're using spool thermocouple, and I have a corrected value of -4. And then survey notes, where I put that note in there. No TC failure. If we had catastrophic TC failure, you would have saw one of those TC lines on the graph drop off, and then in the chart, the Excel looking chart, you would have saw one of the columns go blue-gray, right, which indicates cold or out of tolerance. Okay, here is the graphical trend. Remember, everything we did gets pulled into this report. So we zoomed in on my chart very tightly, so that's all it's going to show. If I want to show that whole chart like you originally saw, I could just close out of this print preview, go back in, modify the chart, and then click print preview again, and it would update. So I'll show. Let's do that. Let's show that. Close. So let's say the chart, I wanted to show all of it. I go up here, click Restore Graph. It goes really big. And let's just say I wanted to show something different, right? Let's say I want to show from 1200 to, I don't know, 700. Let me grab that again. Let's go from 1000. Me personally, I don't like showing too much of a chart scaling range, because you lose a lot of your resolution. And so, okay, good to go. Click Save. Click the Print button again. Generates a print preview. And then now you see more of the graph because I resized it. So print. If you close this out, make some modifications, and then generate a print preview, it's almost like a page refresh, just a multiple clicking method of getting there, right? It's kind of lots of buttons to click. It's kind of redundant, but you get there. Survey sent point 920, minimum TC number 3, minimum TC value 915.8, min deviation from set point 4.2, which means the coldest point of my TUS survey, the coldest point in that chamber volume that I surveyed was 915.8, 4.2 degrees from my set point of 920. Maximum TC was 5, maximum TC value 927.9, or 7.9 degrees from my survey set point. So what that's showing you is your hottest and coldest location in your TUS zone. If you have louvers in your oven chamber, you could possibly manipulate a louver or something like that to change airflow, and change your hot and cold TCs, and maybe try and bring them all in a more normalized range. TC survey results. This reports back on each individual thermocouple inside your chamber, so you can see any hot or cold spots, or if you have huge temperature swings as your oven cycles on and off. But for these purposes, since our survey was a pass, and pretty well centered really, I'm not too worried about it. So next page again, page 6, that chart was big, carries over. So this is your typical, or I should say standard SSI thermocouple probe map. This would be how you would route your thermocouples: 1, 2, 3, 4, 5, 6, 7, 8, and then 9 in the center. I don't like how it jumps around. I prefer a more easy to follow pattern. I just go clockwise myself. Upper right hand corner, 1, 2, 3, 4, jump to the back, 5, 6, 7, 8, and then number 9 in the center. But you can run your TC probes however you want to, as long as you document it. Next page. This is going to be your controller model. Controller PID settings, right? It's blank, not required, not a big deal. In here, surveyed by your name, approved by your 7-level quality department. You can go in and delete that, right? Because there's no requirement for the Air Force to call QA to review your TUS report, because let's be honest, QA is probably going to have no idea what they're looking at. So let's just go by the typical. I suppose if you had like an evaluation by QA, they could evaluate your TUS report, right? If this was a task you chose for your evaluation, but if you didn't, then they couldn't evaluate it. But anyway, moving on. So let's say we're happy with all of this, and we're ready to generate our report. From your print preview screen, you're going to click Print. It's going to save it. You can change your file type down here. I like PDF. If you want to save it in a some Microsoft product or something like that, you're more than willing or capable. I'm just going to call this base X lower chamber. I'm going to get rid of that .sds report. Right, so that's what I'm going to call it. Base X lower chamber 350. Click Save. Generate your PDF file. And there it is. So at this point, you could save this electronically or print it and save it in a hard copy. But I recommend you save it electronically, file it away in accordance with your records management disposition schedule, and be done with it. You know, if you want my opinion, I say you create aircraft tail numbers, and then every part you heat treat, you would save your heat treat record for that part with your aircraft tail number, and then your survey, TUS surveys, you could just create a year folder or something like that, year and month, and throw them in there. So that's pretty much it. When you guys generate this report, you save it for your records only. Do not send it to the Metals Tech office. We do not want your records. This is for individual, I should say section, right? Individual base / section records / auditability. If you ever got investigated, you can pull these records and show them that your operations are in fact up to speed. So that's it. That's how you connect your data logger to your computer, ensure they communicate. That is how you download survey data from your data logger to your computer, and that is how you generate a SSI TUS report. So if you guys have any questions on that, you can give me a call here in the office, Air Force Metals Technology Program Office, DSN 472-4773, commercial 478-222-4773. And again, thanks for watching.